Okay, let's talk about these and see how we're doing. Number one, anyone want to venture to tell me what I should do to both sides to get that x by itself?
Divide by 3.
Very good. Divide by 3 because the 3 and the x multiplied.
Oops, not that one.
And so the opposite of multiplication is division. If I divide by 3, 3 divided by 3 is 1, leaving me just with 1x or x. And
X
then
equals 4.
12 divided by 3 is 4. Yep. I think that's what someone just came on to tell me. The answer is x equals 4. Okay, remember that means I can put it back up here. 3 times 4. We want to know, is that 12? Because that says 3 times whatever x is should be 12, and 3 times 4 is 12, and 12 equals 12. So it checks out. Okay, so that's a one called a one.
Disagree? Okay, what's up, Ryan? Oh, okay, never mind. It was just a catch me not paying attention, disagree. We're okay.
Okay, x minus 7 equals 14. We need to get x by itself. What do we do to get rid of minus 7?
Add.
Add, very good. What do we add?
What are we adding? 7?
Yep, we add 7. That makes 0 this time. X comes down, and 14 plus 7 is 21. So I can put that back up here. So 21 minus 7, is that 14? Use your calculator or you do it in your head. That is 14. And so our answer checks out. So that's another one-step equation. Number 3 is what we tend to call a two-step equation. I apologize for my penmanship. That says 2x plus 1 equals 7. And so we need to get rid of the 2 and we need to get rid of the 1. What should we do first?
Divide?
We can divide, but we're going to make fractions if we divide. Does anyone want to operate with fractions this morning?
Ryan, you up for fractions?
Probably not.
Let's make our life easy.
As my husband says, let's work smarter, not harder. We could divide and we would create fraction 1/2 and fraction 7/2. And if you operated with the fractions correctly, you could get to the right answer. Okay. But in Page, they're saying, let's do an easy way out and let's get rid of that 1 first.
We can kind of do our order of operations reverse, like we're inversing the operations.
Yep. So we're going to subtract 1 from both sides. Our 2x has to come down because it's still 2x. 7 minus 1 is 6. And now we can get rid of that 2 by dividing. And x equals 3. You would get that. You'd get 1/2 and 7/2, and then you'd have to subtract 1/2 from 7/2, and you get 6/2, which is 3. So you would get to the right answer if you divided first, but it's a heck of a lot easier if we don't divide until we absolutely have to. So we're asking the question, does 2 times 3 plus 1 really equal 7? Order of operations says I do multiplication first and then I add. So 6 plus 1, and it checks out. 7 equals 7. Okay, number 4 was the kind of problems that we worked on Tuesday. And what's different about number 4 is that we have x's on the left and the right side of the equation. And so the first thing we want to do is we want to get all the x's on one side of the equation or the other. Okay, because we got to have, in the end, we want x equals a number. And if we have x's on both sides of the equation, we won't get that until we move something. And so you can either subtract 3x from both sides and get rid of this. Or you can subtract 6x from both sides and get rid of that. I'm going to recommend that we subtract 3x. And the reason is if we subtract 6x from both sides, I'm going to get a negative number in front of my x over here. And students make more mistakes dividing by negative numbers than you'd care to realize. And so if we can keep the number in front of our x positive, we'll be less likely to make a mistake. So this makes a 0. I've just basically taken 3 x's off the left-hand side of my pan balance, and now I'm going to take 3 x's off the right-hand side. I'm going to be left with -2 equals 6 minus 3 leaves me with 3x minus 4. And so once I did that and I collected up all my x's on one side, now this is a 2-step equation, just like number 3. And so I need to get rid of, I need to identify my variable. It's over here. And so that means I need to focus on, I got to get rid of the 3 and I got to get rid of -4. Again, to get rid of 3, I've got to divide, and I'm going to create fraction 2/3 and 4/3. Okay. It'd be a whole lot easier to divide at the end. So I'm going to focus on this -4, and I'm going to get rid of that -4 by adding 4. -2 plus 4, the signs are different. So I subtract and I keep the sign of the larger. The 4 is positive, so the 2 is positive. And that equals 3x. And then I divide. 3 divided by 3 is 1, or 1x. And this time we have a fraction that, you know what, we don't get to it till the very end of the problem.
So Mary, like if we have that last step, that's the dividing step, and we make a fraction, so we see that the numerator is less than the denominator, we can kind of know to stop.
Yep, because 2/3, and you can, since the smaller numbers on top or the larger numbers on bottom, if I take 2 divided by 3, I'm not going to get a whole number. You could turn it into a decimal. Okay. So you could take 2 divided by 3 in your calculator and you get a long decimal. Okay. More than likely, you would just leave that as 2/3. If that had been 3/2, you might divide it out and get 1.5. But Julie's right. We know we're done because the numerator is smaller than the denominator. Okay. So it is possible to get answers that are fractions. Okay. Since we left our division till the end, we didn't get our fraction until the very end. If we had divided up here, we would have been working with fractions all the way through the rest of the problem. So it's a lot friendlier to wait for that division. Okay, 1 through 4 are review of the algebra problems that we have solved to date. Are there questions on anything that you see on 1 through 4?
Good.
Okay, 5 and 6 are kind of a look ahead as to what we're going to work on today. And then number 7 is just to begin to look forward to how do we deal with word problems with algebra. So first, numbers 5 and 6. Hopefully this is just simply an order of operations problem. Okay, I have 3 times the quantity, 4 plus 5. Remember my penguins eating Mexican Doritos and salsa, or please excuse my dear Aunt Sally. We do parentheses, we do exponents, we multiply and divide left to right, and we add and subtract left to right. Okay, so by order of operations, we take and we add the 4 plus 5, we get 9, and then we multiply 3 times 9 and we get 27. Okay. Number 6, we have multiplication and we have addition. And so we multiply before we add. So we multiply 3 times 4 and we get 12, and 3 times 5 and we get 15. And we get the exact same answer. And so what this is showing is these two problems are equal. These are 5 and 6. I try and put 5 here and I put 6 here, and they give us the same answer. Okay, because 4 times 5 plus 5 is 9. 3 times 9 is 27. 3 times 4 is 12, and 3 times 5 is 15, and it's also 27.
Sorry.
And the reason that I'm doing this is to illustrate a property that we are going to use today. And that is, if I have the number 3 or a number being multiplied by a quantity, order of operations says I do the not add first and then I multiply. But you can also do this problem a different way. You get the same answer if you take that 3 and you multiply it by each of the terms inside of this addition problem in the parentheses. So I took this 3 and I multiplied it times the 4, and I took the 3 and I multiplied it times the 5. This is called the distributive property. And it says I can distribute this 3. If I have addition or subtraction inside of here, I can distribute this 3 into the parentheses and do 3 times 4 and do 3 times 5, and I'll get the same answer. These two things are equal. Okay. And that may not be very impressive to you at this point, because you're like, well, this is really easy to do. Why would I want to put 3 times 4 and 3 times 5 to get the same answer? That seems silly. And with numbers, the distributive property, you know, isn't that exciting? But as with algebra, I'm going to show you today how the distributive property can help us when we have things like 3 times x plus 5. Order of operations say I should add these before I multiply, but I can't add until I know what x is. But the distributive property says that I can rewrite that to be 3 times x and 3 times 5, which is 15. And this will be useful to us when we start solving problem algebra equations that have parentheses in them. And that's our focus for today. So that's like just a little snapshot ahead. We're going to develop it more in depth, but have this idea of the distributive property in your head. Okay, number 7. This is a word problem. Twice Sherry's age minus 10 is 100. What is Sherry's age? And you can solve this problem by literally just guessing some numbers and trying them. And you can also solve it by algebra. So did anyone solve this problem just by like guessing ages and figure out what the answer is? Okay, boy, Sherry's 90. Nope, she's not 90, because it says twice her age minus 10 is 100. And twice 90 is 180 minus 10. She'd be 170. So that's a little too old for Sherry. Did anybody get an answer to this problem?
Answer? How much? 55?
Okay, we have a suggestion of 55. And how did you get that answer? That is correct.
Sorry, so you said what times? Okay, 50 plus 50 is 100. Oh, and 5 plus 5 is 10. Okay.
Okay. And then did you check it by saying, okay, twice 55 is 110, and 110 minus 10 is 100, okay? And you could use that strategy. You might, let's say you started with, I'm just going to guess 40, okay? Twice 40 is 80, and 80 minus 10 is 70, not 100. That's too small. So maybe you guess 50. And 2 times 50 is 100, minus 10 is 90. We're getting closer, but we haven't hit 100 yet. So let's say you guess 60. 2 times 60 minus 10. 2 times 60 is 120, minus 10 is 110. That's too big. So our 100 lies between 90 and 110. So our answer should lie between 50 and 60. And so maybe you'd guess then, or reason like Ryan did to 55, and 2 times 55 is 110, minus 10 is the 100 we wanted, because it says twice the age minus 10 is 100. Okay. So that is a strategy for solving a problem like this. You can simply guess and check until you find the right answer. Okay. Algebraically, we've worked a little bit with changing words into equations. Okay. So twice Sherry's age, which we don't know Sherry's age, do we? So we're going to put a variable like A for her age. So it says twice A minus 10 is 100. So twice A minus 10 is 100. Okay, twice means 2 times something. 2 times her age, minus we know is subtraction, and is means equals. So I could take this problem and I could write an equation, and now I have a 2-step equation. And what do I do first to solve it? Very good, Curtis. Add 10. And then I divide by 2. Okay. So number 7 is kind of a precursor of where we're going to be heading after our break. We're going to do all this solving and try to get practiced up with just numbers and letters. And then we're going to expand our knowledge and our skill set to work with how do we turn word problems into algebra equations to solve them. So that's kind of where we're headed short term today with the distributive property, and then long term with after the quarter break. So important dates to write down. March 4th through 8th, there are no classes. That's kind of our buffer week. This is when we do progress test, meet with a teacher for coaching or tutoring one-on-one. It's when we like people to take GED tests or practice tests. This is a week for you to kind of plan how you can get some more learning in a little bit different environment. I've left a lot of problems for you in this packet that can be worked and would be a good idea to work for practice. And this would be a great week. You're not learning anything new. We're just taking a holding pattern week for you to kind of see what you think you need to work on to be moving forward in your education. And then March 11th through 15th is spring break. The college is closed. And so March 4th through 8th, college is open. Teachers are available. March 11th through 15th, college is closed. That's our official spring break. And then March 18th, we'll start again with the new quarter. And in this class, what that means is we're going to start taking then our skills from first quarter and start applying them to word problems and being able to solve them, moving forward with our algebra. Any questions about time, anything on the warm up or schedule and timing?
Everyone doing good? Cool.
Okay, we are going to be working on page 42 out of the packet. We're going to watch a video first. So let me get that moved over here. This video is about the distributive property. And we're going to watch just about, we're not going to watch the whole thing. We're going to watch about 4.5 minutes of this, I think is what I decided.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to talk about the distributive property, which is a really useful tool in algebra. And if you watched our video called the distributive property in arithmetic, then you already know the basics of how the distributive property works. The key idea is that the distributive property allows you to take a factor and distribute it to each member of a group of things that are being added or subtracted. Instead of multiplying the factor by the entire group as a whole, you can distribute it to be multiplied by each member of the group individually. And in that previous video, we saw how you can take a problem like 3 times the group, 4 plus 6, and simplify it 2 different ways. You could either simplify what was in the group first, or you could use the distributive property to distribute a copy of the factor 3 to each member of the group. And no matter which way you go, you get the same answer. But in algebra, things are a little more complicated because we aren't just working with known numbers. Algebra involves unknown values and variables, right? So in algebra, you might have an expression like this: 3 times the group x plus 6. In this expression, we don't know what value x is. It could be 4, like in the last expression, but it doesn't have to be. It could be any number at all. And since we don't know what it is, that means we can't simplify the group first in this case. Our only option here is to either leave the expression just like it is and not simplify it at all, or to use the distributive property to eliminate the group. Just like in the arithmetic video, we can distribute a copy of the 3 times to each member of the group, so the group goes away and we end up with 3 times x plus 3 times 6. The 3 times x can't be simplified any further because we still don't know what x is. But we can simplify 3 times 6 and just write 18. So the distributed form of this expression is 3x plus 18. And even though we can't simplify these expressions all the way down to a single numeric answer without knowing the value of x, we do know that these 2 forms of the expression are equivalent because they follow the distributive property. So the distributive property works exactly the same way whether you're working with numbers or variables. In fact, in algebra, you'll often see the distributive property shown like this: a times the group b plus c equals ab plus ac. Or you might see it with different letters like x, y, and z, but the pattern will be the same. This pattern is just telling you that these 2 forms are equivalent. In the first form, the factor a is being multiplied by the entire group. But in the second form, the factor a has been distributed, so it's being multiplied by each member of the group individually. And if you're looking at this thinking, what multiplication? Remember that multiplication is the default operation, which is why we don't have to show it in this pattern. Since the a is right next to the group, it means that it's being multiplied by the group. And on the other side, since the copies of the a are right next to the b and c, it means they're being multiplied also. And even though this pattern is usually shown with addition in the group, remember that it also works for subtraction, since subtraction is the same as negative addition. But the distributive property does not apply to group members that are being multiplied or divided. Okay, so this is the basic pattern of the distributive property. It's usually just shown with 2 members in the group, but remember that it works for groups of any size. We could have a times the group b plus c plus d, and the equivalent distributed form would be ab plus ac plus ad. Here's a few quick examples that have a combination of numbers and variables to help you see the patterns of the distributive property. 2 times the group x plus y plus z can be changed into the distributed form 2x plus 2y plus 2z. 10 times the group a minus b plus 4 can be changed into the distributed form 10a minus 10b plus 10 times 4, which is 40. And a times the group x minus y plus 2 can be changed into the distributed form ax minus ay plus a2, or 2a, which is more proper. So whether you're dealing with numbers or variables or both, the key concept is that the factor outside the group gets distributed to each term in the group. Each term in the group, but
Okay, we're gonna stop there because they kind of go into stuff that from there, they go into stuff we haven't talked about yet. So we are going to be working with algebra problems, algebra equations that have parentheses in them. Okay, so we're on page 42 of the packet. And so they've given us a problem. Actually, I'm going to do one problem before this one. Let's start with a simpler one. So on another sheet of paper or in the margin or wherever you want to write it, let's start with something where we only have variables on one side.
Mary, could you maybe zoom in like one tick,
Yep.
please?
Sure, we can zoom in a couple.
Thank you.
Yep, thanks. Okay, so if we have this problem, remember algebra, we're always focusing on this letter and we're trying to get it by itself. Okay. Order of operations says I should add these first and then multiply by 4, but I can't add m plus 5 until I know what m is, and I'm trying to figure out what m is. So that won't work. And so this is a time when you need the distributive property, and it says I can multiply this 4, I can distribute it to members of the group. So I can take 4 times m, and I can take 4 times 5. And these two things are equivalent. That's the distributive property. Okay, and so that equals 36. And from here, once we distribute into those parentheses, we now have a two-step equation that we already know how to solve. Because I have my m and I have a 4 and a 20, and I'm trying to get m by itself. So I got to get rid of 4 and I've got to get rid of 20. Always a good idea to get rid of the 20, whatever's being added or subtracted first. And then divide by 4. And m is 4. Again, I can go back up here and say, is 4 times 4 plus 5 really 36? Now I can use my order of operations and I can add 4 plus 5. 4 plus 5 is 9. And 4 times 9 is 36. I want to do one more because I want to do one where there's also a number in front of the variable before we look at the ones on the packet on page 42. Any questions on this one? Hopefully what you're seeing is every time we add a new skill, we're going to do the new skill and then we get to a problem that looks like what we've already practiced. Okay, and then once we attack our two-step equation, we get down to something we've already practiced. We get a one-step equation. And so anytime we add complexity, we add the complexity, then we get rid of the complexity and we get back to what we already hopefully know and have practiced a bit. All right, let's try one more. If I have 2 times 3a minus 4 equals 20. Actually, let's not make it 20. Let's make it 16. 3a minus 4 equals 16. Okay. I can't simplify what's in here because I can't multiply 3 times a and subtract 4 until I know what a is. But the same thing, the distributive property says I can distribute this 2 to each member of the group. And when I do I'm multiplying 2 times 3a, 2 times 3 is 6. So I have 6a, and 2 times 4 is 8. Okay, I think it's really helpful when you're distributing to go ahead and just draw those arrows each time. So you want to make sure you distribute that multiplying by 2 to both members of the group. And now I have a 2-step equation. And so I can get rid of minus 8 by plus 8. 6a comes down, that makes 0. And 6a is equal to 24. So now I went from a 2-step equation to a 1-step equation, and I get rid of multiplying by 6 by dividing by 6. 6 divided by 6 is 1, so I have 1a equals 4. I can check my work again. 2 times 3 times 4 minus 4, does that really equal 16? Inside my parentheses, I have multiplication and subtraction, so I would do multiplication first. I still do what's inside my parentheses now. 12 minus 4 is 8. And 16 equals 16. And so that's a check that my answer of 4 is correct. All right, any questions on these two?
Feeling all right, guys?
Cool.
What's up, Brian? On your paper? Okay. So you didn't bring your 6a down. Did you? Added your 8, but then. you
Anyone
didn't-
else has a question? You can put it in the chat.
Does that make sense? And bring your equal sign down too.
All right, if you can move to page 42. Okay. In this problem, the reason I didn't want to start with this problem is it has variables on both sides. So I wanted to start with something a little simpler.
Times 3a. 3a is a term on its own. So you would have 6a.
So in this problem, we have m's on both sides, but we also have this parentheses with an m captured inside of it. So first thing we're going to need to do is the skill that we're learning today, and that is we're going to need to multiply that 7 into the parentheses. Okay. And you can see that what they've done is that exact thing. They multiplied 7 times m to get 7m, and they multiplied 7 times 8 to get 56. Remember that distributive property, it doesn't matter if there's a add or subtract in the parentheses. It works the same. Okay. And so now, if you look, we have these two terms that both have m that are on the same side of the equation. And so if they're on the same side of the equation, we can just add them. That's where we talked about combining like terms. 2m and 7m are like terms because they both have an m, and 2m plus 7m can be combined to make 9m. So that's what they did from this line to the next line, is they put these two together and they made 9m. So now if we look at this problem, we have, and it's rewritten right here, we have m's on the left and we have m's on the right. And so this is utilizing the skill we learned on Tuesday, and they didn't show all the steps, and I still think it's a good idea to show those. So I'm going to write this right next to it. Okay. They went from this line here to saying they suddenly have 12m on this side. And I like to show how I got there, or why you would get there. And if you look, you have 4 minus 3m equals 9m minus 56. So I have minus 3m over here, and I have a 9m over here. And they're on opposite sides of the equation, so I can't just add them together. But I can remove them from one side and do the same operations to both sides of the equation so that all the m's get collected together. Adding 3m is a good idea because I'm going to get a positive 12m over here. And if we can keep the number in front of the variable positive, you will make less mistakes. So this is the skill from Tuesday. Negative 3m plus 3m is 0. And so the 4 comes down. 9m plus 3m is 12m minus 56. And that's how they got this line right here. And if you'll notice, now we have a two-step equation, just like we've practiced for about a week now. I focus on my variable. I've got to get rid of minus 56, and I've got to get rid of 12. Saving my division for the last. Minus 56 plus 56 makes 0. That's how they got to 60 equals 12m. They're not showing their steps, which I wish they did. And now we have a one-step equation. 12 is being multiplied by m. And to get rid of multiplying by 12, we divide by 12. 12 divided by 12 makes 1, or 1m. And 60 divided by 12 is 5.
Everyone feeling all right about this?
Now, I guess I would just encourage you, if you kind of followed along and see how each of those steps are done, then I would encourage you to go back up to this very top part and look at that equation and go, wow, a week ago, I would not have been able to do that, or even follow how to do that. If you're still a little fuzzy on exactly how to do it, that's okay. But if you followed the steps and go, okay, I can see how you did that. Okay, I can see how you did that. We've gone from very simple equations. Remember, we started with something like x plus 4 equals 7. And look where we are now. Okay, so you've learned a lot. If you can follow along, and maybe as we get to the two-step equation, you go, oh, I know how to do this now. I can do this. Then you're improving and you're getting there. What we're learning today is kind of the last of the complicating the equations problems that we're going to do. If you can master through today in solving equations, you've got the equation knowledge you need in order to succeed going forward. Okay. If you're still a little fuzzy on everything, we're going to do some practice and get there, but we've moved a long way from when we started this to today. So pat yourself on the back if you're following along and getting there. Okay?
What's that? Okay. Okay.
Everything we learn is.
What's that? Yep.
Excellent. Ryan's saying, yeah, he agrees that he feels like things are coming together to
Yay.
work out these more challenging problems.
Okay, so let's take a look. We're gonna do a
I
few
agree.
together. And now there's the time when I'm gonna start asking you to give me some input, okay? And that's not to make you nervous, or it's not to make you feel bad. It's if we can start generating some suggestions from you guys, then that helps me to see where we are doing well and where we may need a little bit more help. So when I look at this equation and I look at my X, the first thing I notice is X's are only on the left-hand side. Okay, so I'm not going to have to move X's from left to right or anything. But I also notice I have parentheses and I cannot add X plus 5. So, suggestion, what should I do first?
Use the distributive property. Okay. What does that mean?
Yep, exactly.
8x plus 40. Good. So we're going to multiply the 8 by both terms inside our parentheses. Awesomeness.
Okay, very good. And now we have a two-step equation, and hopefully we're starting to get a little more comfortable when we get to the, I've had a two-step equation point. And I say two-step because I've got all my X's together. I only have to get rid of 40. I only have to get rid of 8 and I'm done. If I subtract 40, that will leave me with 8x equals 56. And now I have a one-step equation. That's exactly where we started all this algebra stuff or equation stuff.
I have a question.
Okay.
So
Sebastian.
with the 8x plus 40, do you subtract because it's addition?
Mm-hmm.
So like if it was subtraction, you'd do the opposite. Okay.
Yep. It's that inverse operation idea. So to get our X by itself, we have to kind of peel away that 40. We have to peel away that 8. And so we use the inverse operations to do our undoing.
We are
So-
undoing adding 40 by subtracting 40. Or if we think about our two-pan balance, I'm taking 40 paper clips off one side. If I'm going to keep it in balance, I've got to take 40 paper clips off the other side. The reason I want to do subtract 40 is it will knock out this 40, leaving me only 8x. And then I'm one step closer to finding out what X is. 8 is being multiplied by X. The inverse operation is division. Division undoes the multiplication, or another way to think of it is 8 divided by 8 is 1. And I'm looking for just one X and what it's equal to. 56 divided by 8 is 7. Good job. Okay. If I put it back up here, 7 plus 5 is 12 and 8 times 12 is 96. Okay, let's try one next to it because it introduces something we haven't seen yet. It's the same property, but it's with some negatives. Okay. So we're going to multiply in. We're going to distribute that -6 to every item in the group or every member of the group. Anyone have thoughts on what's going to happen when we multiply -6 times 6y and -6 times this -1?
Different signs? Mm-hmm. Good. So we have to remember another rule.
Okay, so I'm multiplying. So what will I get when I multiply -6 times 6y?
-36.
Negative 36
Y.
y. There we go.
Nice.
Beautiful.
Okay. Now I have -6 times -1.
Positive 6? We say positive 6 here.
That's correct. Okay.
Okay.
Say that's not -1, that's subtract 1. Remember, I could rewrite that as add -1. And so it's -6 times -1 is +6. Okay. Now I have my two-step equation. I have to get y by itself, so I've got to get rid of 6. I've got to get rid of -36 so that y is by itself. What am I going to do first?
Subtract 6. Subtract 6?
Yep. Zero. So -36y comes down. And we have -102 minus 6, or -102 plus -6. If you need the calculator to help you find these answers, you can do that. And then what am I going to do for my next step?
Divide. Divide?
Yep. And what am I going to divide by?
Negative 36.
Very nice. You want to divide by the -36 because -36 divided by -36 is +1 or +1y. If you divide by +36, your y is going to be -1 times y, and then you're going to have to get rid of that negative. So we can get rid of it right away by dividing by a negative. When the signs are the same and we're dividing, the answer is positive. On the right-hand side, I have two negatives being divided, so the answer is going to be positive. And 108 divided by 36, I just used my calculator. That is 3. Okay. Difference between these first two problems are we had a number in front of our y. So when we distribute in, we have to multiply the -6 times the 6 to get the -36. That's a difference between this problem and this one. The second problem probably looked a little more challenging to you because it had negative numbers distributed throughout. Okay, keeping track of your signs, whether things are positive or negative, obviously is more challenging when you have negative numbers than when you've got, when we're all working in the positive direction, it's easier. Okay. The best thing that you can do for yourself to make sure that you don't make a lot of mistakes or to remove a lot of mistakes is this worksheet does not have enough room for you to work these problems on them. So do your work on another sheet of paper, write out every step, and make sure that you're bringing these things down. Rewrite the problem after you subtract 40, rewrite everything and show your work at every step. What tends to happen is students seem to have an aversion to writing things down and they just start trying to do more and more in their head. And then they've just got random numbers here. And by the time they get to the end, it's hard to know if you've made a mistake or not. But if you'll kind of just plod through it methodically, you'll be less likely to make errors. And you'll also be more likely to be able to find your error if you've made one. Like the other day, remember when I multiplied one side of the equation by 2/3 and the other side of the equation by 3/2? I found out at the end I'd made a mistake, but I could quickly go back. And since I had written down what fractions I had multiplied by, I could see that I had made an error. I could identify it and then I could fix it. So I know there's always this aversion for math students to not want to write stuff down, but you will make fewer errors and you will be able to find your errors better if you'll take the time to do this. Okay, I'll get off my box.
I think Trish has a question.
Yes.
I just want to know.
Uh-huh.
Did they let you use scratch paper of the GED?
Unfortunately, on the GED test, they don't let you use scratch paper, but they do give you a whiteboard to show your work and work
Oh,
problems with by hand. It's to me, I still wish we could have scratch paper for some reason, but that's what you would have to use. And that's another reason why we really advocate that folks take the in-person math test for sure. Because otherwise you actually have to use an on-screen whiteboard and like your mouse to try to do it, which would take so much time even for me, like, and I feel like I would know what to do, but I'd still have to do my calculating, which would take time. So.
Yep, great
yeah, good
question. So yeah, on the GED, you get a paper, like a plastic paper whiteboard and a marker. And then you don't want to take the GED math online. You want to take it at a testing center.
Yeah, I
So
think
let's take a few moments. Let's have you try number 2 and number 4.
Actually,
And we'll talk about those, and then we'll look at the second page of this. And if you get done with 2 and 4 before we're discussing, feel free to keep working on the others, because I'm going to suggest you take those home and, and work on them on your own anyway. So if you've got extra time, you can do it now if you'd like.
And if there's over here. Ryan and Wyatt, are you guys still working a little bit on these two, or Wyatt, you are? Okay. No worries. Yeah, no, you can keep working. I was just curious. No rush or anything. I think we're mostly ready whenever everyone will be.
Okay, I don't know how far you are, but let's take a look and start on these together and we can compare what you've done to date to what we've got together. So can someone suggest what we should do first?
What should we do first, guys?
+4.
2 + 4.
No.
We can't do 2 plus 4 because our order of operations says we would have to multiply. We'd have to do what's in the parentheses and then multiply. And the last thing we would do is take all that and add 2. So we can't add 2 plus 4 because it's being multiplied by these other things.
Any other thoughts? It's all right. Use the distributive property, so where is that happening? Mm-hmm, good. 3A or negative 3A?
Okay, so I heard we want to do the distributive property, and that's correct. We want to distribute this 4 into the parentheses. 4 times 1 is 4. 4 times minus 3A is minus 12A. Now, when we look at this, Tuesday or the week before, I can't remember, we talked about simplifying terms, and now I can add 2 plus 4 because all I have over here is 2 plus 4 minus 12A. So I can put these two together now and make 6 minus 12A. Now I have a 2-step equation. A's are all on the left-hand side, and I've got 2 numbers to get rid of. Got a 6 and I've got a minus 12. Okay, this 6 is positive, and so I'm going to subtract 6 from both sides. That makes 0. And what comes down is this minus 12A. And 42 minus 6 is 36. And now I have a 1-step equation. I have negative 12 being multiplied times A. And so to get rid of that multiplication, I divide by negative 12. Because negative 12 divided by negative 12 is 1. Or 1A, or just A. And 36 divided by negative 12. I have a positive divided by a negative. The signs are different, so the answer is negative. Good job. I'm getting some answers in the chat of -3. Okay.
Everyone seen how that's working?
And we've come a long way in our solving equations. And so if you're still feeling like it's pushing you to keep up, that's okay. It just takes some practice. All right, let's look at the second one we had. We had 4 times m plus 5 equals 2 times m minus 1. Okay, anytime we see parentheses, we should look and see if there's a number in front of it. And so in this problem, we're going to do that on both sides of the equation. Okay, we're going to distribute that number that's in front to each member of this group that's being added. So I took 4 times n to get 4m, 4 times 5 to get 20, 2 times m to get 2m, and 2 times minus 1 to get minus 2. Okay. This problem is like what we worked on Tuesday. We have m's on both sides of the equation. And so we've got to collect them up to where we only have m's on one side of the equation. Since this is a positive 4, and I would subtract 2 to get rid of this, 4 minus 2 is a positive number. So I'm going to subtract 2m from both sides. If you could subtract 4m and subtract 4m, your m's will be on the right-hand side and they'll be negative, which is, again, it's okay. But I like to keep my variable positive if I can. 2m minus 2m is 0. The minus 2 comes down. And on the left, I have 2m minus 20. And now I am down to a two-step equation. I need to get rid of this 20. The opposite of adding 20 is subtracting 20. That goes away to leave me with a one-step equation. 2 minus 20 is the same as 2 plus negative 20, which is negative 22. You can also use your calculator to verify that. And now I have my one-step equation, 2 times m. The opposite of times is divide. 2 divided by 2 makes 1, or 1m, and negative 22 divided by 2, the signs are different, so the answer is negative, and 22 divided by 2 is 11.
How'd y'all do? So? That's okay. We've got lots to keep practicing with, so.
Okay. All right, I want to show you, there's on the next page, on page 43, there's just another situation that's works with parentheses that you can see. And that is when we've got a fraction bar involved in our equation too.
Oh, we didn't get that far last week, did we? Oops.
So you can see this equation here. The right-hand side and the left-hand side, if you ignore this divided by 5, we've been solving, that's like what we just did. So what kind of the thing they're adding into this equation to make it a little more challenging is they're taking this whole left-hand side of the equation and dividing it by 5. Okay. And so we're going to start the same. We're going to distribute that 3 into the parentheses. And when we distribute that 3 to the members of the group, we get 3 times 8x is 24x, and 3 times this minus 1 is minus 3. That's all that's happened in this first step, which is the same as what we've done before. What's different is we now have this divided by 5 that's kind of messing things up. And so when you've got something that's kind of messing things up, we just want to get rid of it. Okay. And so we think about, I can do anything I want basically to both sides of the equation as long as I do the same thing to both sides. And so the opposite of dividing this whole left-hand side by 5 is multiplying the whole thing by 5. And so to get rid of this 5 on the bottom of the equation, they're going to do exactly what we did when we had things like x over 5 equals 10. We just multiplied by 5 to cancel it. And we got x equals 50. We're going to do the exact same thing. It just looks a little more complicated. This whole thing is being divided by 5. And so to get rid of dividing by 5, we're going to multiply by 5. And so they've multiplied the left-hand side by 5 and the right-hand side by 5. And the nice thing is, this 5 cancels with this, and so we get rid of that divided by 5, and all that's left is this 2x minus 3. No more fraction. And then you can multiply this 5 into, distribute it in, and get 5x plus 35 on the other side. So a tip is, if you don't like this fraction messing up your problem, if you multiply by what's on the bottom of the fraction, as long as you do it to both sides, you can get rid of that fraction and turn it into something that looks a little nicer. But you have to multiply the other side by 5, which in this case means everything on that side has to be multiplied by 5. And so we have to distribute in to multiply it by the 5. Okay, and now we have an equation that looks just like what we've done before. We do have variables on both sides. And so I'm going to write out the steps over here because I don't like how they don't show what they did in their problem. So,
They also work horizontally, which is hard to see too sometimes.
yes. Okay, so, and they did it in a different order than I would do it. I always like to collect all my variables on the same
Mhm.
side of the equation before I start moving anything else. And they did it in a different order.
Oh, yeah. Huh.
So I have 24x on one side and 5x on the other. This 24 is a big number and I want to keep it positive. If I subtract 5x from both sides, this number will, in front of the x, will stay positive. If I subtract 24x from both sides, then this is going to be negative over here. So I'm going to choose to subtract 5x. Okay, and 24x minus 5x is 19x minus 3. 5 x's are gone, and so that equals 35. I'm back down to a two-step equation. Okay, I got to get rid of 19 and I got to get rid of minus 3. I do not want to divide everything by 19 because that will make really yucky fractions. But I can get rid of the 3 by adding 3 to both sides. That makes 0, so 19x is left on the left, and 38 is left on the right. Now I have a one-step equation. Hopefully by the time we're getting to the two-step equation, you're going, okay, I can handle this. Okay, and we divide by 19 because the opposite of multiplying by 19 is dividing by 19. 19 divided by 19 is 1, or 1x. And 38 divided by 19 is 2. Now, if you really want to see how far we've come, again, look at the problem that we started with. Okay, look at this problem. That's quite an algebra problem. Okay, and you may be like, but yeah, I don't really quite know that I could do that by myself yet. That's okay. It's okay. But when you look at this compared to where we started a couple weeks ago, my hope is you can maybe follow the steps. My hope for sure is, my real hope for you is, for sure, once we get to the two-step equation, I hope that you can go, okay, I recognize this, I can do this. And then my next hope for you is when you get to here, even though you have variables on both sides, you can go, okay, I think I know how to tackle it from here. And then what we do is we keep pushing your comfort level up the chain to where hopefully you'll get to the point where you can look at that and not totally freak out and say, I can do this one step at a time. But if you're down here where you're like, okay, I'm getting comfortable down here, that's good. And we'll just keep practicing and move you up the chain. Okay, so let's try number 5. They did leave us a little more room here. I write fairly large, so I'm going to still do it on another sheet of paper. Okay, so I don't see any parentheses. So I don't see any need to distribute at this point. So can I get a suggestion of what you might try to do first on this problem?
Thoughts? Multiply by 2.
Very nice, because that divided by 2 is kind of messing things up. Okay, if you don't like that dividing by 2, well, get rid of it. Opposite of dividing by 2 is multiplying by 2. I can do that as long as I do the same thing to the other side. 2 divided by 2 makes 1, which means all I'm left with is 3m plus 1, and my fraction miraculously disappeared.
Hey, it's a miracle.
But now we have 2m plus 1 times 2. I couldn't squeeze it in the front, so I put it in the back. But you know what? That's still 2 times a quantity that's being added. And so I can distribute this direction. I'm distributing that multiply by 2 to each member of the group. 2m times 2 is 4m. And 2 times 1 is 2. Okay, so we've turned this yucky problem into a problem that is not quite a 2-step yet, because I've got 3m over here and 4m over here. I can take and subtract 3m from both sides, and if I do that, I'm going to get a positive m on this side. Or I can subtract 4m from both sides, but I'm going to end up with negative m's on that side. And most people don't like that or tend to make more mistakes. So I'm going to subtract 3m from both sides. That cancels out, making 0. 4m minus 3m is m, or 1m. And actually, this problem jumps from variables on both sides to a 1-step equation. And so what should I do to both sides of the equation to solve it?
Subtract 2.
Yep. I want to get m by itself. The 2 is what's keeping it from being by itself. And so m is -1. Now I want to show you this problem. And I want to just highlight something. If you chose to do it the other way, if you chose, you've got m's on both sides of the equation, and you said, okay, I'm going to subtract 4m from both sides. 3m minus 4m is -1m or -m. You could see it written either way. 4m minus 4m makes 0. And now we have a 2-step equation, because I've got to get rid of the positive 1 that's being added, and I've got to get rid of the -1 that's being multiplied. So I'm going to subtract 1 from both sides. And now I have -1 times m equals 1. And I would divide by -1 to get rid of the -1. -1 times -1 is positive 1m. And 1 divided by -1, signs are different. So the answer is negative, and it's -1. I wanted to show you this because, and we did this on the day when we learned this concept as well, but I just wanted to kind of take you back there. Is difference is I moved the 3m on this one. I ended up with positive m's, and so I went straight to an answer. Here, I moved the 4m. I ended up with a -1 being multiplied times the m, and so I had to deal with that at the end that I did not have to deal with here. And so if you'll move the variables so that you will end up with a positive number in front of your variable, instead of a negative number in front of your variable, you will be much less likely to make a mistake, because dividing by negatives, once you start getting all these negative numbers, things get more complicated. Okay. But you can see we got to the same answer with both methods. It's just this way's a little, to me, is easier because you end up with fewer negatives along the way. Okay. All right, we've upped the ante and upped the complexity. If you are still kind of struggling with the two-step equations or the variables on both sides, what I would recommend is you go back to those lessons, practice those until you feel more comfortable with them, and then move your way through to these harder equations, okay? Because if you haven't mastered some of the more basic, like the two-step equations or variables on both sides, then as we make this more complex, it just gets, you just got so much more that you're trying to learn all at once. So if you're still not quite comfortable with two-step equations or with variables on both sides, go back a lesson or two lessons, practice those, check your work in the back, and as your comfort level increases with those, then move forward and try these harder problems. What we have no more, we're not complicating the algebra anymore for solving equations. This is the top of the line, okay, for where we're going to go. And so we do have next week, we're going to work with inequalities, and we're going to show you how to solve inequalities. And they use the same concepts that we've already been studying. So we'll get to practice them some more next week using inequalities instead of equations. Inequalities are like the less than and greater than symbols. And then the very last day of the quarter, next Thursday, we're going to try and pull everything together, do a little bit of review, and also do some test prep. Like when you have an equation that you're given the equation to solve and it has 4 answers, we can use the answers to help us find the right answer. So I'm going to just do some test taking techniques and tips next Thursday. So next Tuesday's inequalities, next Thursday's test taking tips and review. And then we're going to send you off for 2 weeks of no class. That first week, teachers will be in the office.
Good to see you.
Teachers will be in the office to help you or to set up progress tests or GED tests, but that'd be a great time to kind of, again, practice through what we've learned. Because we'll be at the end of this packet and we'll be starting on something new next quarter. Well,
You
really,
do have lots of extra practice if you finished all the problems in your packet and you need more.
hey, it is 11:31. I hope you have an awesome Thursday, a great weekend, and I hope to see you back on Tuesday. Let's see, Julie, there's science today at 3:30, social studies at 3:30, and language arts at 6 tonight. Okay. I'll be on for just a moment if you have some questions.